So, hey everybody, this is Sly, and here's another update to the bending water test. There seems to be much discussion about the bottom marker. It seems folks think I will be making a level line, which, yes, of course, would require some decent precision optics and know-how from an expert in that field. I am not making a level line, or a tangent if you will. I am making a chord, which is a line between 2 points. There is a monumental difference as it refers to this test. But if my intention were to make a level bottom line, oriented from the observation point, then we would really have to rewrite the book of physics if I wanted the arc to remain above it. And to be honest, when it comes to aligning things, ultimately a theodolite is just like a scope or a camera, just with a really awesome stand. But in the end, it ultimately comes down to a dude looking through an eyepiece to align stuff. But enough of that. Thanks to the assistance of a friend, a large portion of my already raised funds were fronted to me, so I have begun ordering several items which I cannot easily acquire locally. At this moment, I am in possession of the water pump drill head, a strong cordless drill with an extra battery for operating that pump, the marking clamps, the marker light, all the T-connectors, and a measuring wheel. Things that I still have on order from Amazon, which will be arriving in March, are the sponge heads for the tubes, the wind, temperature, and pressure meter, and of course Big Willie himself. Locally, I'll be purchasing the poles, vertical tubes, and the zip ties I will need to erect the vertical tubes. I need to put hands on these items for many reasons, mostly having to do with the fitting of them together. I will also be constructing a simple wheel on a stick, which I will use to remove flow-stopping bubbles. But the last thing that I will order will be the 16 100-meter rolls of tubing. That is only because I lack a bit of storage space, and this will need quite a bit. Recently, 2 trips were made out to the test site. The site is excellent, and big thanks to GeoStraber for finding it. Ultimately, there is only one pivotal concern: weather. Both days that the site was visited were absolutely beautiful days outside, but in that sucked for long distance observations. But better conditions do exist. We will need an overcast day. Even with very light fog would be great. Anything to break up the sun's ability to create temperature-related distortions. Or we can actually wait to do the finer stuff till about an hour before sunset, where the sun's impact is the lowest. As you can see here, the detail that I can get with my little camera, at full zoom level, the folks walking across that bridge are 4.5 kilometers away, and I can make out quite fine detail of the people and the ironwork on the railing. Here's a shot of the marker light I'll be using at exactly 1 mile away. And again, you can see the very fine detail at that distance, as well as the 2 centimeter thick measuring stick being held up. And of course, here was just a simple test shot of the proposed Bingen site, which you can also see great detail at 1 mile where that road sign is. So the success or failure of this test is greatly going to depend on the weather of that day. So let's go over the whole process of how this test is going to be performed. There's basically 11 steps. Number 1. I will set up the observation point and align it with a downrange target so that the whole test is aligned over usable terrain. In other words, keeping it off the bike path. Number 2. Starting at 100 meters from the observation point, the pipe track will be assembled with the 100-meter connector pipes and the upright pipes connected and laying on the ground. The closest pipe will be called pipe 0. The furthest one will be pipe 16, for a total of 17 pipes. Step 3. A vertical marker stake will be placed at pipes 0 and 16 and aligned with the camera's line of sight. Step 4. Starting from pipe 15 moving towards the observation point, vertical markers will be placed in a straight line along the entire track. Step 5. Once all the vertical markers are in place, all the pipes will be erected on those marker stakes. Step 6. The pipes will be filled with water using the pump, and then one long bubble walk will be made to make sure that there's nothing obstructing the flow of water. The pipes will then be left to equalize while the crew and visitors eat for about an hour. Step 7. The marker light clip will be placed on pipe 16. Step 8. Markers will be aligned for the baseline or chord in the following manner. When the light is on post 16, a marker clip will be put on number 15 and slowly adjusted up and down until it is eclipsed by the top of the clip as observed from the OP. The height of the clip will then be marked on the tube and then removed. This process will be repeated on all of their tubes. Once all the tubes are marked, then the clips will all be placed at their marked heights, as well as a parallel clip and of course the water level clip. Step 9. Observations will be made at the height of each marker line, as well as a few offset observations from the observation point. Step 10. I will then walk the line. I will be filming all pipes and fixtures, making height, temperature, and barometer and wind speed measurements at each tube. I will film that entire walk uninterrupted. And then, of course, step 11 will be the breakdown. This will conclude the test, and it should take about 8 hours to complete. So that's all I got right now for an update. As the last few components arrive, I will be letting you know when it is that we'll be performing this test. Again, this test will most likely happen in the later half of April, so we still got a couple minutes to get everything ready. So y'all have a nice day.